A new discovery could finally help answer one of humanity's most profound questions: are we alone in the universe? The mystery surrounding this age-old query only deepens today as reports flood in from the New York metro area. People are spotting more drones than ever before. Could these be simply modern technology at work, or something far more extraordinary? In a similar vein, the James Webb Space Telescope has just uncovered breathtaking images of Triton, Neptune's largest moon, leaving scientists in awe. What they've revealed is truly astonishing: strange, glowing patterns across Triton's icy surface that defy explanation. These mysterious signals might hold the key to something hidden beneath the moon's frozen exterior. But could there be something even more remarkable at play here? Could these signals challenge everything we know about moons and planets in our solar system? Let's dive in and uncover the secrets of Triton, secrets that NASA might not be ready to share, because the truth could shake the very foundations of our understanding of the universe. Triton's icy mysteries. Triton's surface is a stunningly beautiful frozen wonderland. The moon is coated in a thick layer of nitrogen ice, which reflects most of the sunlight that reaches it, making it one of the brightest objects in our entire solar system. Despite its remote location, this frosty world has always intrigued scientists, and it now holds even more allure. There's something about Triton's unique properties that demands our attention. It sits in the gravitational grasp of Neptune, which plays a key role in keeping Triton geologically active. This constant tugging could generate internal heat, keeping the possibility of subsurface oceans alive beneath its icy surface. These oceans might hold the ingredients for life, which is why scientists are eager to investigate further. But there's more to the story. Something unexpected has come to light, something that may redefine our understanding of moons, planets, and the potential for life across the universe. The power of the James Webb Space Telescope. What makes the James Webb Space Telescope so remarkable is its ability to peer into the infrared spectrum. While other telescopes rely on visible light, Webb can see through the icy exteriors of moons like Triton, detecting heat signatures, trace gases, and other hidden features. This ability allows scientists to unlock secrets that have been hidden for millennia. Infrared light can reveal much about the composition of a moon's surface, detecting materials like methane, nitrogen, or even organic compounds. This opens up new possibilities in understanding not just Triton but the nature of icy moons throughout the solar system. Webb's revolutionary instruments are enabling scientists to detect temperature variations across a moon's surface, which can uncover unusual hotspots, potentially revealing cryovolcanic activity or geothermal heat escaping from beneath the ice. Unexpected revelations. Imagine the shock of discovering that a moon thought to be frozen solid is, in fact, an active, dynamic world. The Webb telescope has the capability to detect just such anomalies. A warm spot on the surface could point to water seeping up from beneath, suggesting that beneath the frozen surface, there might be a dynamic and possibly habitable environment. This is not the first time we've encountered such wonders. We've seen similar clues on moons like Europa and Enceladus, which orbit Jupiter and Saturn, respectively. If Triton's hidden oceans indeed contain the right conditions for life, it could open up new avenues in our search for extraterrestrial life. One of the most exciting possibilities is the discovery of cryovolcanoes, volcanoes that spew water, ammonia, and methane instead of molten rock. Webb's infrared instruments are designed to detect the heat signatures of such events, offering critical clues about the geological processes happening beneath Triton's frozen surface. Additionally, the moon's thin atmosphere, composed mostly of nitrogen with traces of methane, is another point of interest for scientists. Webb's advanced instruments are adept at analyzing these kinds of thin atmospheres, providing insight into their interactions with the surface and their role in sustaining potential life. The importance of subsurface oceans. One of the most tantalizing possibilities raised by Webb's data is the potential existence of subsurface oceans beneath Triton's icy crust. These oceans could be kept warm by the tidal forces exerted by Neptune's gravity, an important factor in keeping them liquid and possibly habitable. While Webb cannot directly observe these hidden oceans, it can detect surface anomalies that suggest their presence. A warm spot on the surface might indicate that water from beneath the ice is seeping through, hinting at the dynamic processes that could be taking place far below. If this theory is proven correct, Triton would join the ranks of other fascinating moons like Europa and Enceladus as a prime target in the search for life beyond Earth. These moons have long been considered some of the best candidates for hosting extraterrestrial life, thanks to their subsurface oceans and potential for organic chemistry. If Webb's findings confirm that Triton holds similar conditions, it would be a groundbreaking discovery that would reshape our understanding of the conditions required for life to thrive elsewhere in the universe. A window to the past beyond the potential for life. Webb's observations are helping scientists piece together the geological history of Triton. Its surface is marked by ridges, valleys, and possible cryovolcanic flows, evidence of a dynamic past. These features suggest that Triton may have undergone massive collisions with comets or asteroids, or perhaps experienced intense volcanic activity at some point in its history. By studying these formations, scientists can better understand Triton's evolutionary path and gain insights into the broader history of our solar system. Webb's ability to detect trace gases in thin atmospheres adds another layer to this mystery. Gases like methane, carbon monoxide, and ammonia are often byproducts of geological or biological processes. For example, the presence of methane might indicate ongoing cryovolcanic activity, or perhaps chemical reactions within Triton's subsurface ocean. These gases could be the product of interactions between water and rock, a process that is thought to be crucial for the development of life. The detection of such gases on Triton could be a key step in answering the question of whether life could exist beyond Earth. The challenge of observing the outer solar system despite its groundbreaking capabilities, the Webb telescope faces challenges in observing distant objects like Triton. At over 2 billion miles away, Triton is incredibly far from Earth, and this distance makes it difficult to capture high-resolution images. Additionally, the faint light reflected off icy surfaces requires long exposure times, which limits Webb's ability to observe rapid changes. But these challenges are far outweighed by the wealth of information Webb can provide. The data collected will form the foundation for future missions to Triton and other icy moons in the outer solar system. Scientists are already imagining future orbiters and landers that could follow up on Webb's discoveries. An orbiter could provide high-resolution maps of Triton's surface, study its atmosphere in greater detail, and confirm the presence of cryovolcanic activity. A lander, on the other hand, could analyze surface samples, search for signs of water or organic molecules, and conduct direct measurements of Triton's geology. Protecting pristine environments. As we venture further into the solar system, scientists must also consider the need to protect these pristine environments from contamination. Any future missions to Triton or similar moons will require careful measures to ensure that Earth-based organisms don't inadvertently hitch a ride and compromise these fragile ecosystems. At the same time, scientists will need to develop methods to distinguish between Earth-derived contaminants and potential signs of extraterrestrial life. The search for answers. The more we learn about Triton and its icy surface, the more questions arise. Could these glowing patterns be a natural phenomenon, or do they offer evidence of something far more extraordinary, something that could change our understanding of life in the universe? As we continue to probe the depths of our solar system, the James Webb Space Telescope will be at the forefront, shedding light on these distant worlds and challenging our assumptions. Each discovery brings us closer to unraveling the mysteries of Triton and beyond. Triton's icy world and the possibility of hidden oceans beneath its frozen crust are just the beginning. As we continue our search for life in the outer solar system, Triton will remain one of the most exciting and enigmatic destinations. Thanks to the Webb telescope, we are closer than ever to uncovering the secrets of this distant moon and perhaps even finding the answers to some of the universe's most profound questions.